Good morning. We will have reading material two, which is diode applications. These are the chapter objectives. In other words, makita man po sa objectives sa ang content sa reading material two. So the first objective is, and hopefully we would be able to achieve these. Understand the concept of load line analysis and how it is applied to diode networks. Then we should, after the chapter, be able to be familiar with the use of equivalent circuits to analyze series, parallel, and series parallel diode networks. Understand the process of rectification to establish a DC level from a sinusoidal AC input. And predict the output response of a clipper, clumper, diode configuration. And then being familiar with the analysis and range of application for Zener diode. So I think pili nyo guys sa lisod na kuan. Objective, understand, be familiar. Understand, predict, and be familiar. Be familiar mo kuno, no? So kung tunong-tunong ra, familiar na siguro na. Anyway, in this section, we will have some computations na. And of course, we'll be reminded of the basic concepts of the operations of a diode. Labi na ang forward o reverse bias. So for example, we have a series connection of a diode. Series mo siya, we have a DC source. We have a diode in forward bias. We have the anode here, then connected to a positive potential. Then we have the resistor here as the current limiter. So the diode at forward bias would have this characteristic, di ba? It would have a very small current passing through it. So small dyan na siya, it approximates an off switch. However, if it reaches a certain voltage, then the current would exponentially increase. Yeah. This part here, the diode is already considered as on. Nanay current mo agi. So this is an inherent characteristic of a diode. Mao ni ang curve niya. So if we look at our circuit again, the equation, kay kuan mo na siya, series mo na siya. So we would have E, a generated equation from Kirchhoff's voltage law, the sum of the voltages around a loop is equal to 0. Around a loop ba? O pwede loop, pwede mesh. So total, this voltage here, kung ana siya, so we would have negative E plus VD plus VR, voltage sa resistor. So this would be this. Kung negative man siya, equals 0, di ba? Pag negative man siya, transpose siya, we will have E equals VD plus IDR. IDR is the voltage across the resistor. Current times the resistance. Dire. Ano siya? Please let me know kung dili kayo masabtan or if you have something to add. So if from this equation, we would draw a graphical representation of this equation. Kung ano siya, straight line, di ba? It's a linear equation. So to draw a line representing this equation on the on the plane here, if we let VD mo siya, no? If we let the voltage across the diode 0, we will have IDR. ID is equal to E over R if VD is 0. Putang ta diri isa ka point. If we let ID equal to 0, we let ID equal to 0, P is equal to VD. So at ID equals 0, ID man siya. If ID is 0, V is equal to, V of T is equal to E here. So natay duha ka point that we draw a line connecting the 2 points. Mao ning gawas ni black line diri. So that point where the this line is called the load line. So that point where the load line intersects with the characteristic curve of the device is called the Q point. That's the operating point of the diode. So at this circuit, the voltage of the diode is this, and the current through the diode is this current. This is the graphical analysis using load line analysis. Ana. So the point of intersection is called the point of operation. Kali, and this is called the Q point or quiescent point. The load line analysis is also applicable for other components. This type is the diode. Kaya diode man atong turyahan nga component. Let us look at an example. Dere. So, for example 2.1. For the series diode configuration of figure 2.3a, this one, employing the diode characteristics of 2.3b, kaning na sa right. Determine letter A, the voltage across the diode, VD. VDQ is the voltage at Q point. The current through the diode, IDQ, the resistance, the voltage across the resistor, VR. Here, indicate mo siya. This will be VR, this is VD. And they are in series, so the current through the circuit is the same. This is the same circuit. So we draw a load line on the plane. So the equation here is 10 equals, our diode is silicon, right? VD, mao ni iyang curve. VD equals IDR. So when we draw the load line, we make VD equal to 0, ID is equal to E over R. And then we make ID equal to 0, VD is equal to E. Maoning, 20 milliamperes diri, 10 divided by 0.5 kilo ohm. Then we have the value of the voltage source here, E, maoning 10. Then we draw a line here. Kung asa na siya nag-intersect, sigahon na to itong mata. Tanaw na to kung asa siya natunong, kaning point at the x-axis. Kung asa na siya natunong, that's the voltage across the diode. The voltage across the diode is, pag tutukan siya, tudahan siya tutok, around 0.78 volts. Lisod ko, kanang lihod siya 0.78. 0.78 is exact, but you know. So anyway, at that point, between 0.5 and 1, that's 0.78 volts. Notice, kay graphical man siya, kibutangan niya diri, approximately. Na nagbahog-bahog. And then for the current, gitunog po niya, where in the y-axis or where in ID. Does this Q point coincide? Oy, naa siya sa approximately 18.5. Kana 18.5. Diha. Sila yung pangutana. Then for letter B, what is the voltage across the resistor? VR. May series man siya, so the voltages are the sum of the voltages of the silicon diode and the voltage of the resistor is equal to 10. 0.78 pa rin sa diode. 10 ang kaning sa source. So 10 minus 0.78 mao nang nahimong diha sa ubos 9.22. As a point of checking ha, the voltage source is 10 volts. Walay mulapas ka 10 volts ha. Kaya ang voltage 10 man, asa man panguhaon kung mga labaw na sa 10 volts ang ato ang voltage sa resistor ug sa diode. So if we are solving it, kung lapas siya 10, di na mao. Let us look at another example. It's a continuation actually. Repeat example 2.1. That was the previous example. Using the approximate equivalent model for the silicon semiconductor diode. Sa pasabot, ma-recall ba nato? Do you still remember the approximate model of the diode? For approximate model of the diode, it says that from here, let us look at the blue curve. When the diode is forward biased, it will remain off until it will reach at the threshold voltage. And for silicon, the approximate threshold voltage is 0.7. So the approximate niya, pag abot sa 0.7, our diode is on. Below 0.7 volts, the diode is exactly off. Approximately off siya. Naglatay siya diha sa x-axis. Zero jud iyahang current. So the voltage across the diode is 0.7. Naara. Butangan na to siya o load line, vertical mo na siya. Diha. And the current, 10 supplied by the power source, ang 0.7 ana to as a diode. So therefore, the voltage at the resistor is 9.3. Another example, but I think this is the same circuit. But this time, we use the ideal model for the diode. Okay, repeat example 2.1 using the ideal model of the diode. If we recall, if we use the ideal model of the diode, where it says that If it is forward bias, automatic on siya. If it is reverse bias, it is exactly off. So pag forward to this type, naglatay diri ang characteristic curve sa diode. If it is on, mura dyan siya switch. There is no voltage drop across the diode. See? Now VD is 0 here. And then, if it is reverse bias, exactly 0 dyan siya. There is no leakage current. So for ideal model, the voltage drop across the diode when it is forward bias is 0. It is like a switch man should. Ideal man siya. No resistance at all. So 0 siya kung on. A short circuit would have a 0 voltage across it, but very large current. And then, if we, man yung load line, no? If we look at the intersection here, natunog siya dire. To 20. Kay 0 man ato ang voltage across the diode. So the current through the diode is 20 milliampere. What about the voltage? Wala na magyapon niya. Wala kalimutan din sa author that there is a requirement for B. Naaman, di ba? So if there is no voltage drop across the diode, then the voltage across the resistor is equal to the applied voltage. So here, VD is 0, diode current is 20 milliamperes, and the voltage across the resistor is 10 volts. 10. So now we have already included the different diode modeling for our analysis. So let us try to look at it. Comparing the approximate or showing the approximate and ideal semiconductor diode. If we treat the diode as approximate, wala na kaya-appeal diri ang real diode because at real diode, we would be using this curve. For different diode, we would have a different characteristic curve, right? So for a generic, para mag-uniform tatanan, for actually, for each diode, just like a resistor, na siya a resistor, although the nominal value is say, for example, 100 ohms, the actual resistor might have different resistance reading. Na uban, pila man na. Pero dili siya mulayo ha. If the nominal value is 100, tingali 99.9, ang uban 100.05. So it's the same with the diode. Each of the diode will be a bit unique than its other similar diodes. So para uniform, for approximate diode, yung approximate siya, which is if not required in the problem, we would use approximate modeling. So kung approximate siya, if silicon, the forward voltage drop is 0.7. If the diode is germanium, the forward voltage drop is 0.3. If the diode is gallium arsenide, the voltage drop is 1.2 volts. Indicated siya diri sa schematic. If it is not indicated, it is assumed that the diode is silicon because silicon diode is more popular than a germanium diode for ordinary uses. So anyway, if our diode if we use approximate model for our diode, the voltage drop is 0.7. 9.7 per me. If it is reverse bias, a zero current. For an ideal semiconductor diode, nasa ubos. At forward bias, there is no voltage drop. Okay, 0 volts. And if it is reverse bias, this part here, no current would pass through. ID is equal to 0 ampere. I think na pa yung additional problem. So there. So this is the same. This is a series circuit, series diode circuit. In series siya. Again, I applied voltage na ang diode, and then basically siya, there should be a resistance in series with the diode to limit the current when it is forward bias. So the diode, for approximate would always have, for forward bias, which would always have a 0.7 volts. Yeah. This is a modeling, substituting the diode into its equivalent voltage equivalently. It's as if there is a 0.7 voltage supply there. Nga, 0.7 should siya permit. Hindi siya ma-outro. If reverse bias, okay, if we reverse bias our diode, this is positive and the cathode is connected to a positive potential, the diode acts like an open switch. There is no connection at all. There. So if we are going to, if it is a reverse bias, if we are going to measure the voltage across the diode, buta na to voltmeter. Reverse bias mo siya, no? If we try to measure the voltage across the diode using a voltmeter, we will be able to measure the applied voltage. So this is this. Diha. Open circuit man ang kuan, ang reverse bias. So what would be the voltage that we will be able to read here? Ang isa niya, connected sa supply. Ang isa, connected sa resistor. But there is no current, right? Walay current diha. VR is 0. So it's as if it is a short circuit. So the voltage across the diode, or the voltage that we would be able to measure, is the applied voltage. Kani ihang ma-measure if it is reverse bias. So let us try. Katong ganina nga example, it is solving the for the voltages and current using a graphical method or using the load line analysis. Now, if we use, I think approximately siya, computation for a series connection of a diode, mounting example 2.4. So let us look at example 2.4. For the series diode configuration, ang nasa ubos, determine VD, VR, and ID. So the applied voltage is 8 volts. The diode that we are using here is silicon, and the resistor is 2.2 kilo ohms. Ang pangutana, pila man ni ang voltage across the diode? It is forward bias, right? Silicon siya. So the voltage across it is 0.7 volts. Unang na diha. What is the voltage across the resistor? If the applied voltage is 8, series siya ha. The voltage at the diode is 0.7. Ang nahabilin muna ang voltage sa resistor. So 8 minus 0.7, the voltage across the resistor is 7.3 volts. The problem is from the reading material. I-copy na ako siya. I cropped that from reading material too. So if, for example, later we would like to review what we have discussed today in detail. O na ay makalimtad, nganong naingana na ihang values. I think the details are in the reading material. So what about the current through the diode? Series man siya. Na ay current, mga diha. Of course, mula ho siya. Ito. Right? So the current nga moagi sa diode is the same current nga moagi po dito sa resistor. Hindi man na ito masolve ang current kung magtanaw rata sa diode. But if we are looking at the resistor, we would be able to know the current using Ohm's law. V equals IR. Nanatay V, our V is 7.3 volts. So the current is V over R, 7.3 divided by the resistance, 2.2 K. The current through that's the current sa resistor. That's the same current na moagi dito sa diode. So the diode current is 3.32 milliamperes. There. Next example. Repeat the same configuration, but this time the diode is reversed. If this is our circuit, reverse man siya, di ba? So it look like this. Ano siya? Okay, reverse bias siya. It is like an open circuit. Wala siya connection. Ang pangutana, so ito same kaya pong pangutana. VD, VR, ID. Diba? I-repeat man. I-repeat na to. Bali lang ang diode. Open circuit man siya. Therefore, the current is 0. Ano? ID is 0. Kay 0 siya, the resistance, the voltage across the resistor is equal to, from Ohm's law, ID, VR equals IR. 0 man ang I. 0 po ang voltage sa resistor. Diba? And, as we have discussed, the voltage across the diode, if we measure the voltage here, pwede po the equation sa taas. But generally, visually, nagkaroon na to diha, the voltage at the diode is the source voltage, 8 volts. So if we see, for example, linya sa kuryente, and putol siya, doon na tasyo wala siya kuryente ha. Ay, the moment that you touch it, example ba, it is live, na day voltage, na voltahe diha. Although, actually, wala siya kuryente. But the moment you touch it, you provide a connection for the current to flow. So isolate it, or insulate it, and then do not touch. Especially if kanamikita na to sa kalsada, kasi hindi ay live na siya. So do not touch. kaya makita nimo nga naputol ang wire sa kuryente, nagbitay, do not touch it. So you would provide a connection for the current to flow. I do not know pila man ang resistance sa tao. What is your resistance value? If you are sa basa, if you are dry, sa ba. But anyway, do not touch and open uh, connection. Just in case it has a voltage slide. Although wala siya current, and then you touch it, you provide a current, you provide a path for the current to flow. Kani siya, kung abli siya, wala current. Kaya if yung current would flow, yara siya kutob, siya. Mga tagak ng mga electrons, mga tagak siya. Naa ka diha, diha mo agi ang current nimo. You do not touch any wire. Open siya. So wala siya current. But if we touch it, wala na. Na na tayo current. Agi man sa imuha. Na naman siya agihanan. Kanot ha. Let us have a short break. 5 minutes lang. Ayaw mo pa din bata, mabalik na ta for stretching. So please do some stretching exercises po diha. Let us resume. 5 minutes lang. Then we will continue our discussion. For example, 2.6 ta. Kung di mo mag-stress, basahan, nagkadaghan ang example. I hope pabalik na po ng tanan. To resume our discussion, let us have example 2.6. So what do we have here? This is another series configuration at a voltage source, 0.5 volts, and then a silicon diode, forward bias. The positive potential is there. Then sa opposite, because it's ground potential. Then the resistor 1.2 kilo ohms. The same requirement. Solve for the voltage across the diode. It's a silicon diode. The voltage across the resistor and then ID. Now, if we examine our circuit, the required voltage for the diode, the threshold voltage for the diode to turn on is 0.7 volts. And here, the supply voltage is 0.5 volts. The voltage is not enough to turn on the diode. So although it is forward bias, but the diode will not be able to turn on. Okay, 0.5 volts raman. 0.7 man yung kinahanglan. So here, di siya maka-on. So the diode current is 0. Right? Unang naa diha. And then the voltage across the resistor, this is the equation. So if the current is 0, and multiply ana 0. There. And since 0 ang resistor, voltage sa resistor, applied voltage is equal to the voltages in the component, the talon. So isa 0, 0.5 man ang applied voltage. So ang nabilin, 0.5. So the voltage across the diode is 0.5. So this is the case. The voltage should be enough. The applied voltage should be enough. Although forward bias siya, the requirement for the diode to turn on is one is forward bias. The other is that the voltage applied should be sufficient to turn the diode on. Kit mo tayo, 0.5 raman. Diba? Muta lang. Another series configuration na sa ubos is we have 12 volts. Then we have two diodes. One is silicon and the other is a LED, light emitting diode. Red siya. And then naatay resistor and then ground. So it's a series configuration. Determine VO and ID. ID is the current. Kana. Diha mga ang current. VO is, diri ang VO. I'm not sure if the blue markings are visible. So VO is here, so that voltage here. If we examine it, VO is the voltage across the resistor. VO is actually VR. Diba? If we measure VO, we measure it with respect to ground. Ground naman na. So the voltage VO is the voltage in the 680 ohm resistor. ID is, so po niya ID. Ano na itong equation? Kirchhoff's voltage. E equals 12 equals I think mauna ni siya. Kani siya. Ito lang isulat ito. 12 equals forward bias ang duha ka diode. So the voltage, sum of the voltages of the components, 0.7 plus the voltage across the red lead. Naana sa table, previous chapter, nasa reading material. The threshold voltage of a red lead is 1.8 volts. So plus 1.8 volts plus the voltage sa resistor, current times the resistor. So I times the resistance, 680. So if we look at the equation, we have one unknown, ang I. So if we solve for I is equal to, ano siya, 13.97. Ano yung equation? 9.5 ang voltage sa resistor. If we solve 13.97 times 680, we will have 9.5. Kani siya, giuna niyang, giuna og solve ang voltage, then the current is also solved. So that's a series configuration. So notice from this example that for the LED, there are different. In this particular example, the red LED is 1.8 volts ang iyahang voltage across it if it is forward bias. Not the same for all colors. Kaya lain o threshold voltage ang o forward voltage ang LED code. And for different colors, different forward voltage value. The illustration, 1.8. So pwede, diode magsunod. Next example. Similar, but this time, ang diode, ang duha ka buok, nagsunod siya, but one is forward bias, the other is reverse bias. There. Forward bias siya, pag i-on niya ang current, pakabot diri, uy, reverse bias ng DI. So, open circuit siya. Look at the equivalent model diri sa PCAS. Walay connection. So, the current is 0. Kaning determine ID, PD2, VO. So, ID is 0. Asa man yung ID equals 0 diri sa solution? ID is 0. Diha, I is 0. Isulat niya. 0 ang current. Because the other is reverse bias. Bisag forward ko ng isa. Asa na mabahagi ang current na to, diba? So, okay na ta sa current. Of course, kay walay current, the voltage across the resistor is also 0. VO is 0. VO, ang ipasabot niya at this point here. And VO, the other terminal of the resistor is connected to ground. So, VO is technically the voltage across the resistor. 0 pod. 0 na. 0 tong naguna. What about VD2? Anong voltage dire? So the voltage there is technically from the previous example is the applied voltage 20. Ano siya? VD2 is equal to voltage of the open circuit equals to 20. Next example. We have this series circuit, 10 volts, resistor, 4.7 kilo ohms, and then we have a diode, silicon diode, and then we have a 2.2 kilo ohm resistor here connected to another power supply, negative 5 volts. So the diode is forward bias. At the anode, it is connected to a positive potential, 10 volts. The PCAS, -5. Essentially, it is also a forward bias because the anode is more positive than the cathode. 10 volts positive, kana negative. Diba? Ang pangutana, determine the current, voltage sa 4.7 kilo ohm resistor, voltage sa 2.2 kilo ohm resistor, and then the output voltage VO. This time, VO is not anymore the voltage across the 2.2 kilo ohm resistor. Because if we measure VO, natay natay voltmeter. Example, if we solve for VO, the positive probe would be at VO, of course, with respect to ground. So this will be connected to ground. Dito, dili na dito sa PCAS, kaya ka ng PCAS na tiil sa resistor, negative 5 volts pa na, di ba na, ground. So this time, VO is not the voltage across the resistor. I hope that it made this very clear. Ato na siya sa ground. So this would be VO. So anyway, for the current, saan ba ito equation natin? Equation is, we KVL na. So we would have 10 minus pa V ato ikuan ha V1 pagi ko na ko ha katong one side of the equation voltage source, the other side of the equation is the voltages of the components. So the voltage across from here to here is 10 minus negative 5, right? Equals the voltages of each, that is V1, voltage sa 4.7 plus diode 0.7 plus V2. There. What is V1? V1 is current times 4.7. That's the voltage, right? 4.7 K. V2 is current times 2.2 K. So if we substitute these values to V1 and V2 here, I na lang ang unknown. Right? So if we solve for I, mauna ni siya ang equation, solving for I. I is equal to 2.07 milliamperes. So mauna siya, 15, 10 minus negative 5. Idalhin dito ang 0.7, mauna yung negative 0.7 divided by 4.7 plus 2.2K. Kaya i-factor out ang I. So the current is 2.07 milliamperes. Okay na ta. So V1 is using this 2.07 milliamperes times 4.7K. That's 9.73 volts. V2 is, using this equation, 2.07 times 2.2 kilo ohms. That's 4.55 volts. So what about VO? Pinata I, V1, V2. VO is this, di ba? To ground. Pila mo ni siya to ground. V2 is already, pila mo ni 4.55 volts. If we solve for VO, VO is negative 5 plus 4.55. That's negative 0.45 volts. Yeah, siya, negative 5 naman ni siya. Kung agad tira, that's 4 point, positive 4.55. Then we have, na rin natin nag-measure sa voltage. So that's negative 4.45. Pinataanin. Let us end our discussion here. So series. I might finish up. I I posted lab activity 1 BI. So please practice. Although the chapter is not, we have not completely discussed the entire chapter yet, please practice the related problems at the end of the chapter. Series man siya. Pagkita itong series na dito. And for load line analysis, kita po ang part dito. Yung mga problem. Let me know if may problem na. Ano eh, timang ba ni siya sa example, di ba? Kanang dako jud nga si Mang, asawa ni Simong. And then I also posted the lab activity 1. Let us look at lab activity 1. Next meeting, we will continue our discussion. We will have parallel configuration and series parallel configuration. Let's look at now lab activity 1. I think, I'm not sure, basta na nagani nag-pass. Oh, if you have seen it, dili na kayo tingali siya. Struggle ng activity. Naa siya sa LMS katong laboratory nato nga, I'm not sure kung mauni siya. Pero anyway, naa siya dito na gibutang sa laboratory nato nga subject. For those nga naay partner, isa lang ka buok ang i-submit ha sa assignment. But please write in the document both your names. Ay, masabtan ra siya. The activity is testing diode. How would we know if the diode is good, defective? Imagino na lang. And asa dapit ang cathode, asa dapit ang anode. For example, if the diode is new, naman siya marking, di ba? Kung asa dapit ang cathode, asa ang anode. But sometimes, if the diode is already being used, especially kanang sa laboratory nga diode, permi siya makaptan and the hands are singuton. So usahay ma-erase na ang marking. But anyways, we can use a digital tester or an analog multi-tester to test the diode. So I suggested videos to watch demonstrating how to test the diode. The video are not limited to 2 only. Kung dili na basabtan akong gi-recommend na video, you can try watch other videos. Okay ra. So based on the videos, write a procedure. So in your own, based sa inyong natanaw or tingali kung kulang magbasa ta, please write it in your own words. Write a procedure in testing diode using a digital tester, analog tester, then provide an illustration. And when you test it, you get some reading man sa tester, di ba? Add an explanation. Anong ingana man ang reading if the diode is good or kung good siya expected pero ano man makaingon ka naguba ang diode. Write a technical explanation as needed. And then at the end of the procedure, please make a general analysis and interpretation of the activity. Again, katong naay partner, isa lang ang i-submit ha. And also, please write the names of your duha man ka both your names. Please write the two names of the partners. That is all for today. Please let me know. I'm not sure kung saan ako ni siya. Next week ang due date ani. Please, I think that is more than enough time to finish this activity. However, please let me know kung feeling jud duoy jud kaayo, keep ra jud kaayo ang time allotted for this. So I think time is so more than enough. So mao ni siya. So let me recap for today. Today we have started reading material 2. Started with load line analysis and then we have examples for different series diode configuration. The next meeting we will have parallel and series parallel. Maybe, I'm not sure. Tingali mag-series parallel ta. Then, utol ng sa nato, then we will have our presentation of problem solution. And then we will have our test on next week. Next week pa ta mag-test siguro. So anyway, we have one activity for laboratory. This is all for today. Kung naay idugang, there is still time kung naay ikang dugang. Or if you want to raise a concern. Wala na ko isulti. Ang wala isulti, pwede na mo exit. Hapit na ko mo exit. Wala na ko isulti. Thank you for today and